So today we will be continuing with the inheritance concept which we have been covering over the past 4 lectures, and in this particular lecture we will see the order of the execution of constructors and destructors of various inherited classes. So before going into the details of the code, let me first brief you about the concept which is there behind it. And for example, you have rather let me use some different thing. For example, you have classes. One class is the point class, and you have another class which is the circle class, and you have another class which is the cylinder class, right? Okay, and then this circle class says that point class is my parent, right? And this cylinder class says that this circle class is my parent class, right? So whatever is available with the point class which is not private will be accessible to circle, right? And whatever is available with circle via that belongs to the circle itself, or that belongs to the that has been inherited from the point, will be available to the cylinder class, right? So let me try to show it to you visually. For example, this point has, let's say, two things which are non-private. It can be public or protected, right? And this circle has two things, rather three things, which are all of its own, and it is inheriting two things from the point class. So it has in total 5 things, right? So this cylinder class will not only get the objects, or not only get the data members or variables which are from the point class, but it will also get the data from the variables or functions from the circle class, and it may have something of, let's say, its own. So this is how it works. Now when we make in the, let's say, in the main, when we make an instance of cylinder, right? Remember, I'm not writing any code here. I'm just trying to make sure that you understand the concept here, and then we will be going to the code as well. In the main, let me do it like this. In the main, we make an instance of the cylinder object. Let's call it C, right? Somehow it's some sort of visual representation of what is happening here. So when you make an instance of a class, what happens? The first thing which happens is the constructor of the class is called, right? So when you make an instance of the cylinder C, the constructor of this cylinder will be called, right? But there is a difference between something being called and something being executed, right? So although the constructor of the cylinder will be called, but it will see that I have a parent class. So instead of executing the instance of the cylinder, it will then call the constructor of its parent, which will be the constructor of circle, right? So then the circle will notice that, okay, I have a parent rather. It will call the constructor of the point class, right? So the point class has no parent. Although first of all the constructor of the cylinder will be called, but it won't be executed, right? It will then call the constructor of the circle, and then the circle will call the constructor of point, and then the constructor of the point will be executed, right? So if we distinguish between calling, call, and we say, let me pick some other color, we say execution, right? And let me draw a line here. So although first of all the constructor of the cylinder will be called, then the constructor of the, it will call the constructor of the circle, and then the circle will call the constructor of the point, right? But finally, when the constructor of the point class is called, it will be executed first and foremost, right? And then the constructor of the circle will be executed, and finally the constructor of the cylinder will get executed. So practically speaking, if you see it in terms of output being displayed, which we'll be seeing shortly, you will actually, the thing which you will be able to notice will only be this thing. So actually practically, first of all the grandparent constructor will be executed, then the child, and then the grandchild. So but it gets called, but they never get executed before the parent constructor gets executed. So this is the order of execution, this is the order of execution and of the constructors, right? Remember, order of call is a bit different, but finally when it gets executed, it is something like this, right? So this was for constructors, right? And let's assume that some instance, rather the same instance, the cylinder instance is being destroyed. Now the order of destruction will be total opposite, right? First of all the cylinder will be destroyed, then the circle will be destroyed, then the point will be destroyed. So when I say the cylinder will be destroyed first, it means the destructor of the cylinder will be called first, and then the destructor of the circle, and then the destructor of the point class, right? So this is the order of execution, right? To briefly sum it up, the order of execution of the destructor is totally opposite to the order of execution of the constructor in case of inheritance, right? So I hope this is clear to you. And now let us go to the code. Let me go through these slides just in case if I missed something. Chain of constructor calls, derived class constructor invokes base class constructors, right? It invokes it as I explained it to you. Bases of inheritance hierarchy, last constructor called in the chain, last constructor, by last constructor mean the parent, the grandparent, which is the eldest one, or which is the base class. And destroying order is totally reverse, as I explained to you earlier. So I've already uploaded these things at CMS. You can access the book. The book is available there as well, and the slides are available there as well, so you can go through them. Now let us come to the example. Here we have a class point, the same class which we have been studying over the past 2 or 3 lectures. So in this class point we have 2 members, as we had earlier. We have a point class constructor. We already discussed this in previous lecture. We have a display function of this point class. We already discussed it last time. So the thing which is new is this destructor, right? So this destructor is there, and I have already explained to you what is a destructor. And in this destructor we are simply displaying a message, point class destructor, right? And the rest of the code is same as we studied previously. However, there is one addition of a line in the constructor, which simply displays the message point class constructor, right? So this is the only difference between the present code and the code which we did last time. Okay, let me show it to you. This was the code we were talking last time about. So the code is same, with an exception that in the point class constructor we have an output line, and we also have a destructor this time here, like this. The rest of the code is the same. Now we have another class which is the circle class as before, and it states that point class is its base class. So it is inheriting everything from the point class, which is non-private. So x and y comes here to the circle class, and this circle has its own variable named radius. So there is no big difference between the previous code and this one, but we have a destructor here, and in the constructor we have an extra line displaying the message circle class constructor, and in the destructor we are simply displaying circle class destructor, right? So the rest of the code is same, and then we will be having a third class, which is the cylinder class, which makes the point class as its base class. It has its own variable height. Rest of the code is ditto same, with an exception. We have a destructor here displaying the message cylinder class destructor, and in the constructor we have an extra message displaying that cylinder class constructor. Rest of the code is same. Okay, now in the main when we in the main when we make an instance of the cylinder class C, now if you see, first of all, this point class constructor is being called, although what will be happening that we have a point, we have a circle, and we have a cylinder, right? We have a cylinder, right? And what will happen here is that although we have made an instance of the cylinder, but it goes to the circle, and then circle goes to the point, and finally the first thing which gets executed is the point class constructor. So although the cylinder class constructor is called, which then calls the constructor of the circle class, but and which circle then calls the constructor of the point class, finally the first thing which gets executed, difference, there is a mind the difference between something being called and something being executed. Okay, we gave a call to the cylinder constructor, but it did not executed, got executed, then it went to the circle, and then it went to the point. The first thing which got executed was the point class constructor, then the circle class constructor got executed, and then the cylinder class constructor got executed, right? And if you see this code here, we are simply making an instance here, and then the main is getting closed. So now here at this place, this object of the cylinder will get destroyed, and if you see the order of execution of the destructor, it is totally opposite of that of the order of execution of the constructor. So first of all, the cylinder class gets destroyed, which got created in the last, but while getting destroyed, it is being destroyed first and foremost, then the circle class gets destroyed, and finally the point class gets destroyed. So I hope the order of execution of the constructors and destructors is clear to you, right? Then we have another concept which is called function overriding. Although I did explain it to you in the previous lecture in detail, because the function overriding concept is extensively, not extensively, rather it is being used, simply being used in this case study of point, circle and cylinder. So I thought it better to explain it to you in the previous lecture, but for the sake of completeness, since we have got some content over it here, let me repeat it, that in function overriding, let me rather read it out. The function in the derived class with the same name, Okay, this is important. With the same name will override the function in the base class, right? So it is important to have same functions with same name in the base class and derived class, right? Let me explain it to you. For example, we have a class, let's say circle, and it has a function display, right? It has a function display, and we have another class, let's say square, right? And it has a function named display as well. And this circle says that point is my base class, right? And what we can do here is that in the display function of this square class, we first of all call the display function of the parent class, which is the circle class, and then we add some functionality of our own in this, right? So this whole of this concept is called function overriding. And let me give you another view of this. For example, again we have another class. We have in a different scenario, we have a class circle, and this class has again a function named display. Again we have another class square. Okay, and this square class says that circle is my parent class, right? Same scenario but a bit different. I wait for it. And in the square class, in the display function, we wanted to display or put something on the screen, maybe see out some measurements of the square or circle. So here in the square class, we have a function named print, right? Right, we have a function named print. Okay, and in this print function, I can legally actually simply call the base class function, and then it can have additional functionality of its own, right? So the only difference here is that here we have named the display function, which is the same function, which is the same name which the base class has for its display function. But here in this scenario, let me name them. This is scenario 1 and this is scenario 2 for the sake of clarity. So in the scenario 2, the same functionality is being executed here with an exception that instead of having the function to see out something in the child class, instead of having it the same name as that of the parent class, we have changed the name, right? The rest of the concept is same. So maybe apparently you can say that it's function overriding, but actually it's not. Okay, function overriding is a concept. So this is function overriding. The main concept is that the name of the function in the base class and the derived class should be same. But here if you see in the base class we have the function name display, but in the derived class the name of the function gets changed. So although it will be working the same, but you cannot call this concept as function overriding. You can do this, it will execute, it will work perfectly fine, but the only restriction is that you cannot call it function overriding, right? But you can call this as function overriding, right? This is actually important from the point of view of object oriented analysis and designs. I previously I cannot recall the lecture number, but I told you that there are two things. One is called object oriented programming, which we are studying presently, right? And another thing is called the uh, object oriented analysis and designs. So when the software architecture when a software architect basically designs an object oriented based solution, he draws it using various tools, various softwares. For example, there is a diagram which you will be studying in your software engineering course later in your degree, which is called class diagram. So there the software architect basically instead of writing the code, he draws a diagram sort of, which is the class diagram, and the programmer at the end of the day receives that class diagram and programs it. So if the software architect has used the concept of function overriding there, then he would have used the same nomenclature there. So it is important to understand that having the same names in the base and child class for the function overriding concept is very important from the software design perspective. Otherwise, if you write a simple code and if you change the name, it won't affect any execution feature. It will work fine, but you cannot call that operator overloading then. Okay, so what is important is that in the function in the derived class with the same name will override the function in the base class, right? So the rest of the concept is same, and I actually previously told you that okay, if you have same name function in the base class, okay, wait, in the base class and in the derived class you have same name function, and if you are in the derived class and you want to call the function of the base class, because both have same name, it has also display, this one has also display. So what you can do, you can simply write the name of the base class if you want to invoke the function of the base class, not the child class. Simply write the name of the base class, then you write the scope resolution operator, and then simply call the function. So in this case it will call the function of the base class. But if you do it simply like write the name of the function and then you call it, and in this particular case it will execute this its own function, right? We actually did it last time, so there is no need to go into further details. Right, so I hope it is clear. And now coming to the long awaited concept of types of the inheritance, right? Okay, for example, we have a class, let's say student, this is a class, okay, and class ends here. We have some coding here, blah blah blah, right? And we have another class, its name is BS CS and students, right? And we have this class, okay, and we have some code here, and now here we want to make this class as our parent class. So what we'll be writing here, we'll be writing colon public and student, right? Now sorry, now this public basically refers to the type of inheritance which we are doing, right? So so to explain, these are basically, I'm skipping this because I will be explaining it shortly. These are the actual effect on the public and private and protected type of inheritance, but it's a bit complicated to explain. So but I will be explaining it to you in the easiest possible way. Then all of this thing will become very clear to you, right? Right. Now yes, here. Now what happens here, let me declare something. I for example, I have a variable x, I have a variable y, I have a variable z, right? And let me assign different access specifier to each of the variable. For example, for the x I say public, right? For y I say protected, and for z I say private, right? And where is the inherit? Oh, and this is the code, right? Now if you see, in the public type of inheritance, when we inherit something from the base class, everything which is non-private, right? This thing, that this is private, so it is not going to be inherited, right? So let's forget about it. Everything which is non-private, it means that x and y, x will be available here and y will be available here, right? So in the public type of inheritance, the public variables of the base class respectively become public variables of the child class, right? And the protected variables of the base class respectively become the protected variables of the child class, right? Um, the in the public type of inheritance, whatever you inherit from the base class, if it is public, it will be public in the child class, and if it is protected, it will become protected in the child class, right? So this is what happens in the public type of inheritance, right? Now the second thing is, if we change it and we say no, we are not going to make public type of inheritance, we are trying to inherit something, inherit a class, and the type of the inheritance will be protected, right? So in the protected type of the inheritance, again this private stuff of the base class is not available to us, right? Only public and protected are available to us. In the protected type of inheritance, x and y will be available in the child class, but this time everything which is being inherited, from the base class, and it is being received in the child class, it becomes protected. Becomes protected. Sorry for this. So in the protected type of inheritance, everything which is received from the base class becomes protected, right? And in the private type of the inheritance, in the private, oh, I think I, okay. In the private type of the inheritance, whatever we receive from the base class, again private is not going to be accessible to us, but x which is public, y which is protected, we will get it, x and y we will get it, but now these x and y in the child class, they will be private, right? So let me do it like this. For example, what happens here is, okay, I hope it's visible on the same screen. Okay, let me remove some stuff. Okay, now here in this type of the inheritance, what will happen? Public x, don't mind the case, please. It's a case sensitive language, but excuse the case insensitivity here. protected protected y, right? Now here private xy, and here no. Oh, let me fix it. Oh. And this one is public. Wait a second, I'm explaining it. Now, sorry. Now, if you see in this public type of inheritance, this private never gets inherited. If the type of the inheritance is public, if the type of the inheritance is private, if the type of the inheritance is protected, you never get the private stuff of the base class, right? So forget about it. But if the type of the inheritance is public, the X which was public there will respectively become public in the child class, and Y which was public in the base class respectively become public in the child class, right? In the private type of inheritance, X and Y, irrespective of the fact that one is public and the other one is protected, both get received in the child class, but they both become private. And in the protected type of the inheritance, these both things gets inherited, and irrespective of the fact that they are public or protected, they become protected here, right? So this is the simple explanation of the type of the inheritance. So whatever I have explained here, it is written here as well, just in case you feel like reading it, you can read it, right? And remember that the friends of the base class never gets inherited. So the further details you can see it here. So I hope it is clear to you.